In this task, we'll look at projections suitable for the U.S. states, in particular, the state plane coordinate system. The state plane coordinate system was developed to provide a simple rectangular coordinate system, otherwise known as a Cartesian coordinate system, for large-scale mapping use, such as surveying and engineering projects. It's actually a series of separate coordinate systems, each covering either an entire state or a portion of a state, depending on the size. State plane is only used in the United States, so it isn't appropriate to use state plane or even possible to use state plane in other countries or regions of the world. It's popular due to its high accuracy and large-scale mapping because of the relatively small size of each zone. The zones are so small that you're not having to flatten out as much curvature of the Earth as you are, say, with a map of the entire lower 48. Here I have QGIS Desktop open with the Vermont QGIS map file open. Just one theme, the Vermont layer. Let's start by examining the CRS of our map. I'll go to Project, Project Properties, and I'll see that the map is in WGS 84. One interesting note, the map is in WGS 84 because the Vermont layer is in WGS 84, and when the first layer is added to QGIS Desktop, the map will adopt whatever CRS that first layer is in. And just to verify this, we can also check the spatial reference of a layer by right-clicking on it, going to the properties of the layer, and on the General tab you'll see the coordinate reference system for the layer. So you can see the layer and the map are both in the same WGS 84 CRS. If we wanted to make a map of Vermont in Vermont State Plane, we have two options for doing so. We could either enable on-the-fly CRS transformation in the map and put the map into Vermont State Plane, in which case our Vermont layer, which is in WGS 84, would be projected on the fly into Vermont State Plane. Or we could project the Vermont shapefile into Vermont State Plane and set the project's coordinate system to match. So we've seen that enabling on-the-fly projection allows more accurate measurements when using WGS 84. It also allows you to have GIS layers in different CRSs. When that's the case, each layer in the map will be projected on the fly into the CRS of the map, and all the layers will align properly. However, if you're going to do an analysis, it's a best practice to have all of your data layers in the same CRS. So here I'm going to project the Vermont shapefile into the Vermont State Plane zone. To do this, I'm going to right-click on the Vermont layer, and from the context menu, choose Save As. The Save Vector Layer dialog window opens. I'm going to save it as a shapefile, but if I wanted to, I could change the format from this format drop-down. Next, I'm going to click the Browse button and navigate into our Module 3 Lab folder and go into the Data folder. I'm going to name this new shapefile. Here I'll be saving out a new copy of the layer, and I'm going to use a naming convention. I'm going to call this Vermont_SPCS. Since I'll have two versions of this Vermont shapefile, I'm using a naming convention to indicate what the difference is, so the coordinate system is referenced in the title of the layer. Finally, I'm going to click the Browse Coordinate System button, and I'm going to choose from the Coordinate Reference System selector Vermont State Plane. This is EPSG code 32045. I'll put that into the filter, select NAD 27 Vermont, and click OK. Those are all the settings I have to specify, and I'll click OK. QGIS has reprojected the Vermont layer and added it to the map. So as you can see, it looks just like the previous version. It's just in a different random color. Let's revisit the project properties and look at the CRS. And you can see that previously Enable on-the-fly transformation wasn't enabled, and now it is. This has happened because QGIS realized that layers in the project had different CRSs. With on-the-fly CRS transformation enabled, the two Vermont layers still display on top of one another. The state plane version is being reprojected in this case into WGS 84 on the fly. If on-the-fly CRS transformation was not enabled, the two Vermont layers would not display in the screen at the same place. They would be in two very different coordinate spaces, and we wouldn't be able to see them together. Click OK to close this. Now let's change the project CRS to match our state plane shapefile. I'll simply right-click on the state plane shapefile, and from the context menu, set project CRS from layer. And you can see down in the lower right-hand corner, the indication that the project is now in Vermont State Plane by the EPSG code changing. And you see the shape of Vermont change as a result. Another thing we can do is apply the styling from the original WGS84 Vermont layer to the new State Plane version of the Vermont layer. To do this, I'll right-click on the Vermont layer in WGS84 from the Context menu, go down to Styles, Copy Style. Then I'll select the State Plane version, right-click on it, go down to Styles, Paste Style. Now our new layer has the same style as the original. GIS layers can be removed from the Layers panel in the map window as easily as they were added. For example, we don't need the original Vermont layer anymore. We can just work with the version of Vermont in State Plane. To remove a layer, simply right-click on it and choose Remove. Click OK. So now we've reprojected the original Vermont layer into State Plane, applied the original style to the new layer, and removed the original since it's no longer needed. Along the way, we also put our map into the State Plane coordinate system as well. So here you've seen more ways that you can work with spatial reference systems within QGIS Desktop. In Task 5, we'll explore the Universal Transverse Mercator, or UTM, coordinate system.